The Autoflight System, AFS, on the Airbus long-range family is designed to assist the pilot in flying the aircraft within the normal flight envelope, hence enhancing safety and optimizing performance. This module is an introduction to the AFS. Let's begin by building up a basic conceptual diagram. The AFS can be thought of as consisting of 4 main sections. At the heart of the system is a computation and processing section, the brain. The central processing section has access to several information sources. The pilots have access to the central processing section via input devices. Finally, after computation and processing, commands are provided to output devices. For the AFS in the Airbus long-range family, computation and processing are done by 2 Flight Management Guidance and Envelope Computers, FMGEC. The 2 FMGECs are identical and normally work together, so for training purposes, we will group them as the Flight Management Guidance and Envelope System, FMGES. The FMGES receives navigation information, which contains details of airfields, nav aids, airways, routes, waypoints, procedures, SIDS, stars, approaches, missed approaches, etc. Aircraft performance information. The Air Data and Inertial Reference System, ADIRS, and the Global Positioning System, GPS, for position and dynamic information. You will learn about them in the navigation chapter. The clock and radio navigation information. The pilots provide inputs to the FMGES using a single flight control unit FCU for short-term interventions and 3 multipurpose control and display units MCDU for long-term interventions. The FMGES provide outputs to the flight directors, FDs, and autopilots, APs, for pitch, roll, and yaw control, the autothrust, ATHR, for thrust control, the MCDUs and EFIS for the display of information, and the navigation radios for the automatic tuning of radio aids. The FMGECs are divided into 3 main parts: Flight Management, FM, Flight Guidance, FG, and Flight Envelope, FE. Note, a 4th part called FIDS exists, but it is for maintenance only. The flight management part of the FMGES controls the following functions: navigation, the position of the aircraft and the estimated accuracy of this position; flight planning, the flight plan computation; performance optimization, costs, speeds, and altitude optimization; predictions, the accurate estimates for waypoints, altitudes, speeds, fuel, destinations and alternates; and finally, display management, the control of information to the EFIS system to display autoflight modes and navigation information. The flight guidance part of the FMGES provides flight director commands for the pilot to control the pitch, roll and yaw, autopilot commands to automatically control pitch, roll and yaw, and auto thrust commands to automatically control thrust. Flight envelope FE part of the FMGES provides flight envelope computations, e.g. minimum speed, such as VLS, or maximum speeds, such as VMO or VFE. Maneuvering speed computations, best speed to fly at in a given flap configuration, backup gross weight and center of gravity computations, wind shear and aft center of gravity warnings, and flight management and flight guidance parameter monitoring. Note, the flight control computers also process some flight envelope speeds, and they control many flight envelope functions, such as protections. You will learn more about this in the Flight Controls chapter. As a general rule, the two FMGECs have access to information provided by on-side sensors, except for certain parameters, e.g. clock, or in case of failures. They exchange information for validity comparison purposes. For example, information from MCDU-1 is received by FMGEC-1 and transmitted to FMGEC-2. All FMGECs and MCDUs are then synchronized. The third MCDU is provided as a backup in case of failure of MCDU-1 or 2. It then replaces MCDU-1 or 2. In normal operation, it is used for other functions, such as ACARS or ACMS. The inputs from the FCU are fed to both FMGECs. Both FMGEC FG parts send commands to the autopilots, flight directors and auto-thrust systems. According to an internal logic, one FG is declared master. E.g., if autopilot 1 is on, FG1 is declared as master. This determines, amongst other things, which of the two autothrust channels is in use.
The controls and indicators found in the cockpit are one Flight Control Unit, or FCU, two Flight Director push-button switches located on the EFIS control panels and the associated EFIS displays, three Multipurpose Control and Display Units, MCDU, and two A330 or 4 A340 thrust levers, mainly in interface with autothrust.
You have just seen an overall presentation of the autoflight system. In the next modules, we will review each component in greater detail.